This problem will take a little bit more time, so I'll get started very quickly. In this problem, we have 4 sets of data from an experiment, and we are asked to determine the rate law. In order to determine the rate law, remember we're going to be checking hang on here, there we go. We're going to be looking at this, these 3 reactants. For Br03 1 minus, we're going to find 2 experimental trials in which Br changes, but the bromate and the hydrogen remain constant. So for this one, we're going to use trials 1 and 2. And we've done one of these in class already, in our online class. So I'm going to leave off what I'm going to call our superfluous data. On the left side of the equals sign, I'm going to use the higher of the 2 rates, which is 2.4 times 10 to the minus 3 in the numerator, and the lower 1.2 times 10 to the minus 3 in the denominator. I can see that that equals 2. On the right side of the arrow, I'm going to put the larger concentration, the one that goes with the 2.4 times 10 to the minus 3 in the numerator, and the value for 1 in the denominator, and I get 2. Let me finish this. Bring this to the x power x. Evaluating this, I can see that x equals 1, so this is first order in Br03 1 minus. Then let's look at Br1 minus. For this one, we're going to, I got to turn that off to change my size. For this one, we are going to use trials 1 and 3. 1, we can see this is held constant, and the hydrogen is held constant. So for this, I don't know if I left enough room there. I might have to erase that. Sorry about that. I'm going to put the rate for 3 in the numerator, and I'm just looking at this. This should probably be 3.6. I'm looking at it, and I'm seeing that I had 3.6 in my other data that I was looking at, so I'm going to go 3.6 times 10 to the minus 3. And in the denominator, I'm going to have 1.2 times 10 to the minus 3. So that's going to equal 3. And I'm going to have this value, 0.30, and 0.10. These will be both raised to the y power. So I get 3 to the y. And of course, again, y equals 1. So this is first order Br1 minus. And then the third reactant I'm going to write down here is hydrogen 1, or hydrogen plus. And for this, let's use trials 2 and 4. Trial 2, I've got 5.4 times 10 to the minus 3rd, and I've got 2.4 times 10 to the minus 3rd, and I believe that is 2.25. On this side, I've got 0.15 to the z power and 0.10 also to the z power. So I get 1.5 to the z. Z, in this case, equals 2. So this is second order in the H3O1 plus. To write the rate law for this problem, the rate is equal to lowercase k times BR03 minus 1 times BR, these are both to the first power, and last but not least, this is to the second power. We have one more part of this problem where it asks us to solve for the value of k. The value of k can be solved by using any line of data. And I'm going to cheat a little bit on this one. I believe that the answer for this, if you substitute any line of data into this equation, I believe that you're going to get a k of 12 moles to the minus 3, that's a minus 3, s to the minus 1, and I believe you'll get liters to the positive 3. So moles to the minus 3, liters to the 3, and s to the minus 1. I think that's the units, but double check that. I'll even write that. Double check.